Okay, we're going to do lesson 8, problem 4. And we're going to find a derivative of f of x, which equals the square root of x over x. So we're going to start with the derivative, d over x, square root of x over x equals derivative of the derivative of x. And we're going to do the distributive property, square root of x over the square root of x times the square root of x, which equals derivative of x over 1 over the square root of x. Alright. Which equals 1/2, a negative 1/2, and x to the negative 1/2 power minus 1, which will equal to 1/2 negative and x to the negative 1/2 minus 2 over 2 power, which will equal to negative 1/2 to the x to the 3 over 2 power. When continuously going, we will come up with negative 1/2. So 1 x3 over 2 equals a negative 1/2 and a 1, 2 over x cubed. These will be your derivatives right here. Okay, now we're going to do number 9 of lesson 8. Determine the points at which graph of f of x equals x to the 4th minus 2x squared plus 3. Alright, we're going to start with the derivative of f. Over the derivative of x equals 0. And then we use the power rules with these to substitute. So 4x cubed minus 4x equals 0. X cubed minus x minus 0. We're also distributing as well. X times x squared minus 1 equals 0. Where x can equal 0. Or x squared minus 1 equals 0. Also, the absolute value of x minus 1 times x plus 1 equals 0. So x can equal 0 or x minus x squared minus 1 equals 0, which x can equal 0, x can equal 1, or x can equal negative 1. Then when we put those in, we have a f of x equals x to the 4th minus 2x squared plus 3. F of 0 can equal 3, where your points will be 0, 3. F of 1 can equal 1 minus 2 plus 3 equals 2. And the points of 1 and 2. And then an f of negative 1 equals 1 minus 2 plus 3 equals 2, where your points will be at negative 1 and 2. So those, when x can be 0, x can equal 1, or x can equal -1. And these will be your points right here. And we're going to do lesson 10, problem number 4, where we're going to find the chain rule. Use the chain rules to find the derivative of f of x equals 5 tan 3x. So f of x equals 5 tan 3x, which equals derivative of u 3x with the derivative of u over derivative of x equals 3. And f of n equals 5 tan u, which could be the derivative of f over the derivative of u equals 5 secant squared u, which the derivative of f over the derivative of x equals the derivative of f over the derivative of u times the derivative of u over the derivative of x equals 5 secant squared u times 3. The derivative of f, we fix that, and the derivative of f over derivative of x equals 15 secant squared u, 15 secant squared dx. Then we're going to do problem 11, is find the derivative of f of x equals tan squared x minus secant squared x. This is also from lesson 10. So sine squared x over cosine squared x minus 1 over cosine squared x equals sine squared x minus 1 over cosine squared x, which equals cosine squared x over cosine squared x, with f of x equals 2 tan x times secant squared x minus 2 secant x, which equals 2 tan x secant squared x, that would be multiply, minus 2 secant squared x plus a tan x, which equals 0. And equals 0, and the derivative of the derivative of x and s will equal 0.